Beautiful people, and welcome. In today's video, we are discussing how to graph a base e function. Now, this is an exponential function that happens to have a base e. Now, what is e? E is the value that 1 plus 1 over n to the nth power approaches as n gets larger and larger. Now, if you're in my class, I did ask you to watch a previous video. We're going to watch that in class as well, of what exactly e is. Now, e is an irrational number. It goes on and on and on. You know, it doesn't end. It goes on forever. Like, for example, an irrational number is pi. E is one of those things. So we abbreviate e as 2.72. Now, typically we will write things in E. You will see E. Just know that E is a numerical value of 2.72-ish, right? That's not the exact value. It's irrational, so it goes on forever. But we're going to be using that as our base in our exponential function. Now, for our graphing, the parent function is f of x equals to e to the x power, where e is your base. The domain of that are all real numbers. Now remember, domain are all possible x values. So in a parent function, the domain of your parent function is all real numbers. So it can go negative infinity all the way up to a positive infinity. Now your range for the parent function does change a little bit. The smaller term is at 0 and the highest term is at infinity. Now keep in mind, infinity, you can't grab infinity. Infinity is a concept. You can always have infinity plus 1. So we are putting a parenthesis on that side. Now for range, for 0, can y ever be 0? Can we actually reach 0, or does it approach 0? Well, let's play around with the parent function. So again, your range are all of your possible y values, or your outputs. So if we have e to the x power, well, let's take a look here. Let's do, where's my e? Let's find this out together. Here it is, e. Oh, that is natural log. Let's do second e. And so you're going to see this. And let's plug in any value. So we want a small value because x can be anything. Well, what if x is negative 375,432? And our question is, can it be 0? Oh, and it can be 0, right? It approaches 0. So we are going to put a parenthesis there. Now, this is 0. Doesn't mean it actually is 0. It means it approaches 0. It gets super duper duper close to 0, but it doesn't actually touch 0. Because I want to show you, if I do even a bigger number, still 0. Even a bigger number, 5. Can that all be equal to 0? No. So what that means is that this function approaches 0 in the y values, but it doesn't actually touch 0. So we're going to put a parenthesis there. So let's talk about the y-intercept. The y-intercept for this function is, what is it for this function? For this function, the y-intercept is at 0, 1. Another point for this function is 1, e. For your n behaviors, as x approaches infinity, y approaches infinity, and as x approaches negative infinity, y approaches 0. The asymptote for here, that is your horizontal asymptote, and that is at y equals 0. So how does this thing look? Let's go ahead and sketch this out real quick to see how this function behaves and looks. Let's start with our 2 points. We have a y-intercept at 0, 1. So here's 0, here's 1. Another point we have is 1, e. So here's 1. So this is where you need to recall what e is equal to. So e is equal to 2.72. So here's 1, 2, 3. So e is 2.72. If we have 1, e, so it's around here-ish. So looking at here, E is greater than 1, so if you're recalling your exponential function, if the base is greater than 1, you have an exponential growth, so that means we are growing all the way up. We have an asymptote at y equals 0. That means that that line is something we don't touch, we don't cross. And that line is here at y equals 0. You notate an asymptote with a dotted line. So here's your dotted line. And so we're going to go exponentially closer, 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 closer to that 0. We're not actually touching, so there's always going to be a gap. So as your x's get bigger, your y's get bigger all the way to infinity. As your x's get smaller, your y values get closer and closer and closer to 0. However, it doesn't actually touch 0. It approaches 0. So let's talk about how to graph a base e function with transformations. Now, your transformations are that of exponential functions, are that of original functions that we did when we were first starting transformations. It's always the same thing. K is going to be your vertical shift, up or down. H is going to be your horizontal shift, left or right. A value here is going to be your vertical stretch or compression. All of that remains the same. Let's talk about our parent function here. This is our parent. Again, our first reference point was 0, 1. Our second reference point was 1, e. Our asymptote was y equals 0. Let's talk about our transformations. So for our first point is no longer at 0, 1. Our first point is at h, a plus k. That should be familiar. Our second point is at h plus 1, a e plus k. Again, this is a times e. Let me rewrite that. Just so you know, again, these are the same things. I just wanted to make sure you know. And your asymptote is at y equals k. Take a moment to write that down. Again, we are multiplying the base with your a plus k. It's just like an exponential growth function that you did in the previous lesson. All right, let's move on. Go to example number 1. Example number 1 is asking us, given a function of the form g of x is equal to a times e to the x minus h power plus k, we want to identify the reference points, we want to state the transformations, the asymptotes, the domain, the range, and we want to graph this function. Now, here is the equation that they give us. So let's go ahead and start with, the transformations. You don't have to go in order as long as the information is all there. So let's talk about the transformations. Notice that you have a minus 1 here as your h, you have a k here, and you have a 3 here. So what that means is this right here is your horizontal shift. That should be an h. Horizontal shift, and you're shifting to the opposite. So if this is a minus 1, you're actually shifting to the right 1 jump. This k value is your asymptote as well as your vertical shift. So this is vertical. And you are shifting up 4. Here is a 3, which means you have a vertical stretch. So it's stretched vertically by a factor of 3. So we have our transformations. Immediately, I want to jump into stating that our asymptote is 4. Again, our k value is our asymptote. So asymptote. And that is y equals 4 for our k value. We want to do the domain range. We did the transformations. Let me shift back up here. We did the transformations. We did the asymptote. We need the domain and range. I'm going to choose to wait on the domain and range, and I'm going to skip to identifying the reference points. So for the reference points, you know that your parent function are these, but they're going to transform. And the first point transforms to h, a plus k. The second point transforms to h plus 1, a e plus k. So all you have to do is now take your values, plug them in. Your h value is -1, right? Here, but you're going to do the opposite. So if you see -1, you're going to do the opposite. So in this case, you are doing a -1, excuse me, a +1 because we're doing the opposite. And here we're doing A, which is 3, K, which is 4. So our first point here, our first point is no longer at 0, 1. It is actually a 1, 4, 5, 6, 7, 7, 1, 7. Our second point here is 1, H plus 1, and we have A, which is 3, E, which is E, and plus K, which is 4. Now, sometimes what you're going to see is you're going to see these values here actually written as 3E plus 4. And that's okay. You just need to recall that E value is that 2.72 value. So when you're graphing, this is the correct format, but when you're graphing, you can approximate that value, just so that way it can be easier for you to graph. So it's going to be 2, that's a 2, and then 3 times 2.72. Now, what I'm going to do is I'm actually not going to type in the 2.72. Go ahead and multiply that to your E. So I'm going to say 3 times, I'm doing my E value, and I want E, just E. So you can do either, let's see if it's going to let me on here. No, it won't let me. You can just do the first power. We just want E. Anything to the first power, right, is itself. So we have 3 times E plus 4, and that gives me this big old number. So 12.15-ish, right? Ish. It's about that value. So our two reference points are 1, 7, and our second reference point is 2, 3e plus 4. Let's go ahead and graph those. Now again, you are human, you are not computers. I am not a computer. So this is a rough sketch, just like this is an approximation. We have two values. We have 1, 7. So here's 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to go up to 12. I'm going to go up to 13. Barely made it on that 13 dot because I know I'm going to need to go up here to 12.15. So 1 is 7, 1, 2, 3, 4, 5, 6, 7. Here it is. And then we go around to 2. And that's 12, almost 13. So that's going to be here-ish. Again, it's an approximation. Now you want to see where your y-intercept is. So your y-intercept is setting, let's do a thinking bubble here. So for y-intercept, you're going to set x equal to 0, and then you're going to solve. Again, it might give you not a pretty number, and that's okay. These are just approximations because E is irrational. Sometimes the values you get are also irrational. So you're going to say y is equal to 3 times e to the 0 minus 1 power plus 4. Go ahead and type that into your calculator. And that gives me around 5-ish. 5.10, so about 5. So here's 0, 1, 2, 3, 4, 5-ish, about here. Now, one last thing that we need to do is we need to identify where that asymptote is. We know that asymptote is at 4. What that means is you have a vertical imaginary line that you are going to show with a dotted line that we shall not touch and we shall not cross. Nothing below that line exists. Nothing on that line exists. So we approach it, but we do not touch it or cross it. So when we are graphing, you're going to go exponentially up and you're going to curve and you're going to get super duper close to it with an arrow, but you're not actually touching that line. That line shall not be touched. That line shall not be crossed. And there you have it. You have graphed your exponential function with a base of e with transformations. All right, beautiful people, thank you so much for watching my video. We will do plenty of examples in class, and I will see you in my next video. Bye.